Hi, everybody. Sir Dylan Kimler speaking. Welcome to the podcast. Today's topic is about approach procedural. So in my earlier days, once, like many other air traffic controllers out there, we kind of gave up trying to explain to friends and family what our job actually is all about, because a lot of people think that air traffic control is somebody that stands on the ramp or apron and marshals the aircraft as they come into their parking bay. And you just, as an air traffic controller, you just accept that. But you know inside you that there are way more procedures involved than just marshalling an aircraft. And our focus is a safe, orderly, and expeditious flow of air traffic. Today, talking about approach procedural, the reason for that, I've had a lot of listeners and a lot of people and friends, family, asking about this particular discipline. When I first went to study approach procedural, I realized that this is quite a complex topic, and it was not something that was easy to understand straight off from, working through the manuals and listening to our instructors in class while we attended the course. We also had the opportunity to work with this in terms of a simulator environment, but it was very hard to actually understand the complexity of this discipline, because it's something that you are managing without being able to see. So it's almost like you are blindfolded. And so just let's go back to that scenario with the marshaller that we supposedly refer to as air traffic controllers. Put the blindfold on the marshaller and you equipped him with the necessary batons. He knows that the aircraft's approaching because he can hear it, but he can't see it. So he doesn't really know what he must do. In our case, as an approach procedural controller, we cannot hear the aircraft and we cannot see the aircraft. So our sensors have been removed. And we now still have to manage the aircraft in an airspace that we tasked to provide the management of air traffic, these aircraft at any stage. Sometimes as the controller, we can, and I've experienced that, where I can go outside and I can look up in the sky and I might see that aircraft that I'm busy working with in flight. And it's just like a backup for me. I say, yes, there's that aircraft. I know that's where the aircraft is. But generally, that's not how approach procedural is done. We work in front of a set of flight progress strips. And on these strips, we write in information about the relevant aircraft. So why was approach procedural actually introduced? I'll get on to the more nitty-gritty of approach procedurals shortly. I'll just give you a bit of introduction to it. So approach procedural was introduced because at the time, the idea of radar had not yet surfaced, so had not been implemented, and they found that there was an increase in traffic flow, and the service provision to ensure that traffic are managed as safely as possible required somebody to provide this type of service to aircraft at higher levels. In other words, a person sitting in a control tower can still see his traffic flying in the circuit. He's got a pair of binoculars to assist him and visual reference, weather dependent, of course. But the aircraft are not all going to fly at those low altitudes, and they're not all just going to fly inside the pattern, the circuit pattern of the airspace. So, they've got to go somewhere. And in order to do that, they've got to climb. The higher the aircraft goes, the more economical the flight. So they're not going to fly at low altitudes from point A to point B. So approach procedural came about prior to the advent of radar. When radar came in, it was not something that superseded or replaced approach procedural. That was still very much a discipline to be managed. But it made the job of the air traffic controller slightly easier because they were able to now see their target on display. And this the target would take on different forms because there was different types of surveillance radar that was utilized. So the approach procedural controller is looking at these flight progress strips in front of him, and he's marking the aircraft call signs and the information about the aircraft, such as aircraft type, persons on board. He has to gather all this information, and sometimes this information will be provided in advance. This would all depend on, of course, coordination between the various ATC sectors about the information that can be supplied. And then the ATC is going to manage these aircraft based on the facilities that they have available to them. In other words, navigational beacons that they will bring the aircraft from or take the aircraft to. And they will also hopefully have an instrument in the tower, not all, was in the control center, let's call it control center rather, which is called a VDF. So VDF stands for VHF Directional Finder. Very interesting instrument because it works off of the transceiver. So that's the radio inside the aircraft where the pilot selects their PTT, their push to talk, and a signal is activated on this VDF. In other words, it gives them a bearing of where the aircraft is, depending on what selection the ATC has selected on the VDF. It will tell them where the aircraft is going to or where it's coming from. Okay, so this is called a radial, and it just depends what is selected. It doesn't tell them what the heading of the aircraft is, so they can adjust the VDF readouts. In other words, they can ask the pilot to give set calls within a time frame of, say, 3 minutes, and by getting those calls, they can log each entry that they get off the VDF, and then they can determine from that, more or less, so it's an approximate, what heading the aircraft is flying. If they're not going to work on that, they can still say what direction the aircraft is flying in. In other words, what we call a cardinal reference, being north, south, east, or west, and for northeast, southeast, southwest, northwest. Okay, so we look for those 8 cardinal positions. We can go further, get further involved, and make it 12 cardinal reference points, but we don't have to be that intricate when it comes to this type of management of the aircraft. Now we've worked out that what heading they're going to need, fly the aircraft to the station or where they are from the station. So those are called Q codes, and the QDM is the magnetic bearing to the station, and the QDR is the position or radial from the station. So this is up to the ATC as to the selection that's taking place inside the control center, and that is a manual input by the ATC. It's good to understand the basics of this instrument. Okay, so that's just one of the features of the equipment available to the ATC, but he's relying, in terms of approach procedural, he's relying heavily on the information supply team that he can enter on the flight progress strips, and he also is relying on his flight progress strips so that he can update the position of the aircraft and move these strips accordingly. Now, what he has to do is, in order to provide a full service, he has to provide a separation between the aircraft. Now, the minimum separation in this type of airspace, called a TMA, terminal movement area, is 1,000 feet. In order for him to supply that, he can mark his flight strips and check the altitude or flight level of the aircraft by referencing his flight strip. But in order to separate aircraft, because remember, they're not all going to fly at this perfect height for ATC. That aircraft's got to climb, it's got to descend, and there's also what we call en route traffic, so traffic flying through his airspace. And ATC is going to have to manage this accordingly. So he's going to apply a separation technique. That separation technique is where the approach procedural management comes from, and that is working with angles. And we were talking about a distance known as DME, and the angle in degrees. Now, there's various types of separation applications that are used. And it depends which state you are working in, where in terms of what separation application you're going to apply. Now, this is not something that's straightforward because there's so many different types of separations that you can apply. Inside of that, you've got lateral separation and you've got longitudinal separation. So we've mentioned vertical separation. Now we've got the angle and the distance, lateral and longitudinal. Then we've also got a time-based separation. Okay, so lateral, longitudinal, time, and vertical. The person working in the position of approach procedural needs to be fluent when it comes to calculations. These are quick calculations, so you don't have to be somebody that's going to write a theorem or come up with some type of formula. The formula is already provided for you. You just need to apply it and work out what's needed, the minimum criteria for that application. So that's where I'm going with this, is you've got to be quite quick in determining the calculations, subtraction or addition. It's not complex math. It's something that requires you to be quick and accurate. You don't sit with a piece of paper next to you and you're doing this all fancy and then bringing it to the flight strip. This is something that you have to do fairly quickly. So most of the time you're doing these calculations in your head. On one of my posts, on my private posts, I don't think I've posted on the Talking Radio group, it says that ATC has also been referenced to wizard and magician, which is, it's just a bit of humor to it. But basically, yes, you're supposed to, you're performing this feat of separation, which nobody else knows what you're doing, only you applying it. Of course, the ATC colleagues around you will know that, and if somebody's watching what you're doing, the headset on and they're watching what you're doing, and they're an air traffic controller that works in the same discipline, they'll understand, they'll see where you're going with it. But this takes time. This is not something that can just be passed to you. Even once you've completed your course, as I said in the beginning of the podcast, once you've finished the course, it says you're qualified to go and apply this separation. But the controller who goes out into the field is still going to get what's called OJTI, on-the-job training instruction, from a qualified ATC. Is going to teach him how to apply these separations and the more preferred separation for that particular area. Okay, so this is an unknown discipline to those on the outside. Visitors to the center come and the controller, and in my experiences with it as well, they're looking at the flight progress report and they're seeing that you're talking, but in their minds, they're looking outside of the tower window. They're trying to see where these aircraft that you're talking to. And this is not something that you can really explain to the visitor in a short space of time as to what you're actually doing, because they would definitely not understand the concept. For them, they see the aircraft on the ground, and on the taxi, aircraft landing, and they're assuming that you're speaking to them. My father spent a lot of time with me when he was still around. He spent time with me in these control centers. I tried to teach him these various disciplines. When I say teach, is introduce him to it, not make him an air traffic controller, but just introduce him to it. I failed dismally with this because and that's when I realized, that this is just not something that everybody can grasp. It's something that will definitely require focus and concentration and understanding. That's the most important part of it. So when the person applies the separation, they need to be 100% sure that they've got the angle, that they've got the distance to allow the aircraft, for example, to climb or descend through the level of another aircraft, if that's the separation that they're applying. So if you were going to want to really apply this and find out more about approach procedural, the application thereof, you'd need to attend a course. For someone to become an air traffic controller, they don't just jump straight to this particular discipline. There's a training methodology that's applied anywhere in the world for a controller to eventually reach this standard. So if you're looking at the pros and cons or advantages of approach procedural, one of the pros of approach procedural is that it ensures the separation between the aircraft that you are tasked to apply for your particular state. And if all else fails, you obviously apply your 1,000-foot vertical. So it's a huge draw card. It does work. It's a guaranteed form of separation. You could have a possible reduction in the sense that the pilot's altimeter is faulty. So in which case their height is not telling you or what they're supposed to be at. So there is an error there, but that's not something that's coming from the air traffic control side. So the ATCs rely on the pilot to manage their flight according with safety mechanisms and procedures as well. A disadvantage of approach procedural is it slows traffic up. What does that mean? If you're working on radar, which we'll discuss in another podcast, you'll find that, or you can facilitate more aircraft inside of your airspace. Whereas for procedural, you'll become saturated in the airspace much quicker because of this type of separation technique that you're applying.
End of approach procedural, section 1.